So welcome everyone. So this is real-time data management in the cloud. When you came into the session, what do you think this session is about? Come on. Service bus? Let me see. No. It's service bus is definitely a way for me to put the message passing through. But real time is much more than that. And we're going to talk about things like difficult questions, like what's big data? Come on, any one of you. What's big data? One?
Data that is big.
Who wants one? Okay, last time this worked. I had chocolate bars. So last weekend we did user group. It was the Global Windows Azure Bootcamp. And everybody was doing questions and nobody was getting replies. So I used a trick. I went to the bags, to the lunch bags, and stole all the chocolate bars. And basically, when I started my session, all chocolate bars everywhere. And it's like, as soon as I did a question, everybody's answering, and I was throwing chocolate bars. That worked well. In Portugal, when I was still in Portugal, there was an event that, for some reason, the flight of one of the speakers got delayed, so he couldn't come in. So he basically said, so instead of you paying my ticket, you just go and buy chocolate bars. And as soon as people come in, you just give chocolate bars to everyone, and I'll be online. For some reason, he received max score. He's amazing, but with chocolate, come on, the session was pretty cool. I ate 3 or 4 or something. That's the reason. Okay, so real-time data management. First, who am I? From someone that's always mumbling. My name is Nuno Godinho. I'm Portuguese. I'm Director of Cloud Services for Europe in ADD Technologies. I've been working in the cloud since Windows Azure was actually Red Dog. So now we went from Red Dog to Windows Azure to Microsoft Azure. So I'm old. So we started there, and I've been constantly, even before, one of my passions has been how can I try to help more the business and make decisions faster. So things like I work with stock markets. That's the typical one when you think about real-time decisions. I work with stock markets with one company that wanted to automate most of the things. Now we have all the bots for Xboxes and things like that. Just before, we had to build it from scratch with things like, hey, I just won 5 indexes. Oh yeah, that shouldn't be good. It shouldn't be really bad. So here's a stream of events. It just has 5 million messages going per second. I was like, sorry, didn't get that. 5 million messages. Okay, what the hell do you want me to do with that? Oh, now you need to make decisions, discover patterns. Excuse me? Are you high or something? It's like, yeah. And by the way, I want to store everything. It's like, now you're messing with me. Now I'm sure you're messing with me. And we had to do it. Basically had to do it. And now more and more, this is coming. Now with the power of the cloud, this is easier to do. It's not easy, easier. Well, it's still not there. Okay, so this is basically me. I'm a Windows Azure MVP. I'm an MVP for the last 7 years, last 4 in Windows Azure, and Service Bus Champ, which is a similar thing. Anyone knows N Service Bus? No? Shame on you. That's another topic. So, what's the challenge with real-time data? What's the challenge? Challenge is, a lot of data need to process in real time. So the problem is, what's real time? What's real time for you?
There is a formal definition of real
There is a formal definition, exactly.
You have to be deterministic and specify a certain amount of time in which you can respond to them.
Exactly, but different people, when go through that definition, look from different perspectives. If I'm in an emergency line, for me, real time is actually real time. I'm talking about milliseconds because that actually can change everything. In the stock exchange market, it's milliseconds. I need to make a decision. It's between losing everything or making a lot of money. If I'm in something which doesn't require that speed, probably for me, real time, it's near real time because the real time concept is very blurred. It's near real time. Okay, I can quote with decision in 1 minute, in 2 minutes. That's for me, it's enough. So different people have different views. So if I'm someone doing this monitoring, basically look at a lot of screens, black screens with a lot of graphs. Basically, imagine this is the Windows Azure Operations Center. It's actually prettier. But imagine this. Do I need to receive data in real time on what's happening in order to keep my SLAs? Of course I do. Of course I do. If I'm working in, okay, bad joke. If I'm working in airline controller, do I want to try not to lose my planes? Yeah, that probably might be sensible. So different people have different views. We first need to define what's real time for that specific business, for that specific person, for that specific app. Until we get there, we're basically not talking the same language. It's like going to somewhere and say, we're moving into the cloud, and everybody has a different decision and perception of what the cloud is, exactly like big data. So when we go and we do that, it's basically around, when we think about this, is about different data sources. I have multiple data sources. Now, Internet of Things, the next big thing. Internet of Things and M2M. Anybody already saw any part of the Build keynote yesterday? No? I saw a little bit. I tend not to sleep. It's just a waste of time. So basically, I was seeing, and there was pretty cool things like Cortana, which is the new thing that personal assistant on your Windows Home. I think I'm going to have a blast with that. But then all the sensor information. More and more, our systems are getting sensors. Our wearables. For example, who has Fitbit? I don't, because I get depressed when I look at it. It's like, holy this crap. So all of those elements, imagine all of those generate information from you. What about if I could actually get that information and do something? NoSQL databases, table storage, social feeds. People tend to use social feeds. Who only puts in Facebook, only puts professional stuff? Nobody. Almost nobody. It's true. People, the blur between the personal information is getting blurrer and blurrer. We need to start, if I'm, for example, a telco, I'm not going to say the name of any telco or any broadband because we're recorded, they can sue me. So imagine I'm a broadband company or something. Wouldn't I want to understand if someone is telling something on Facebook, immediately understand that there is some bad sentiment generating and act on it immediately? Because there are studies that tell that if you are the type of person that goes on Twitter or on Facebook and puts a thing, this vendor is crap, if they reply you in a 5-minute window and they solve your problem and give you something, you will actually put the thing also. And basically the bad sentiment goes to amazing sentiment. Because the second one is the one that is going to get mostly shared. Is this interesting for companies? How can I do this without having real-time monitoring? I can't. Data document stores, Relational database, of course, it's still where our data is. Trading desks, weblogs. Yeah, weblogs still have something. Imagine, not saying that exists, imagine that I could go and imagine I'm a telco. I am a telco. I have basically now they have pretty much everything. So telephone, TV, home phone, Wi-Fi spread all over. It's free for you to use. You basically connect. You say, okay, I agree with the terms. Has anybody actually read the terms? Yeah, perfect. Typical. I didn't. So basically, that's amazing. Now imagine that I could, based on everything you do, even only with the data, I could correlate everything. So you're connected to my hotspot. You're doing this kind of search. I know who you are because I know your phone. Because most of the times you need to authenticate with your telco information. So I know pretty much everything about you. I can profile you. I can target you with my campaigns. And I can understand what exactly you're trying to search for. And then we can start seeing those amazing ads that keep following you like, I know I received an email about having a holidays. Please stop following me. Right? This is what we can do. And weblogs actually give you a lot of this information that you normally throw away. So it's about getting all these kinds of data sources into the mix. So then, what can we do with that? Dashboards, yeah, that's the typical one. But more, fraud detection mechanisms. So I want with my credit card, I want to make sure that I'm actually going to avoid there is a fraud. There are some things I need to do in real time, and we're going to look at the 3 examples of real-time processing, which normally, in order for things to go well, you normally merge several things. You have real-time and you have batch processing in order to get things right. So fraud detection, of course, if I have my credit card being used in 3 different countries at the exact same time, it doesn't take, it's not rocket science. I can't be in 3 places at the same time. It's impossible. So this I can do, but then I can create a score. That's where I need the batch historical information. Business alerts and notifications. For example, Internet of Things, more and more the big factories are more automated. And they have sensors everywhere and RFIDs and everything. So as soon as things start to move, and they are mostly automated. I was in a distribution center, and everything was automated. So would it be interesting for me to, as soon as things are happening, to get business information asking, hey, your stock is going to run out. Can I actually proactively go and request to increase the production? What's my limits? Would that be cool? No? So this is the type of thing. Personalized web, we already know. They keep following us and throwing stuff at us in order for us to buy. So the complexity, this is cool, but it's complex. So the complexity is, for example, if I'm in manufacturing, if I have sensors on just one floor, I normally have around 10,000 events per second. Not a lot, but still high volume for me to process. If I'm in web analytics in the clickstream, I'm normally around 100,000. Stock trading, it's 1 million. This is per index normally. And then power energy, which is going more. So I don't know if you know, but as in stock trading, energy has a similar kind of market. It just works not in such a real-time kind of decision. So for example, there was a power plant, an oil rig in Norway that used Windows Azure. The goal was to, as everything was being produced, they could basically throw something like 2,000 instances in the cloud, do the calculations, and shoot into the market. That basically gave them the edge of 24 hours over competition. That basically gone in their business went up because they were able to create that. And the same type of thing that is in financial services, the decisions buy, sell, it's the exact same thing. It just goes a little bit slower. So this is the type of complexity. So, yeah, that's really cool. Why the hell should I care? Is this interesting? Yeah, because this is what we're going to be doing and what we're asking to do today. So we normally have historical trend analysis. Things like we have our BI capabilities, data warehouses. How many of you built data warehouses? Cubes and everything. It's amazing. When someone goes and tells, oh, I now want this dimensions and all of this, yeah, of course, we just need to recompile. I was with a cube, working with a company where a cube, in order to reprocess, took around 6 months. It was amazing. So it's like, I do a question and the damn thing takes 6 months to answer. Amazing. I think I don't remember the question after, I don't know, 10 minutes. I have a memory of a goldfish. Forecasting in enterprises needs to be around days, hours. I need to understand because this is the decision making. But if I go to financial services monitoring systems, they need to be now. So, in the cloud, how do I make sure that my system is running? How do I keep my SLAs? How do I validate the SLAs from the cloud? So I have a cloud provider, I'm using their services, and they say, everything is okay, we're keeping our SLAs. And I trust them, right? I didn't do anything to validate them. Is that true? Should I? I should. Because sometimes you can say, yeah, mine wasn't. Here is the proof. For that, I need monitoring now. I need to have my system, since we are talking about when it's in the cloud, we're talking about the system that needs to fail over very quickly. I need to have the information. Even one of the best practices for a cloud solution is to have custom performance counters around operations. So if I'm connecting to Windows Azure Storage, not only I'm going to count the execution time, but also how much time I took in order to connect into storage. How many attempts did I have to do in order to, if there is an average of this, I'm going to basically fall back to a secondary storage account, secondary system. I don't want for them to do that for me, because they will do it when the platform itself goes down. I need to be proactive doing my things and monitoring what's going on. So, and when we map this with the current analytics, this is traditional data warehouse, active data warehouses, so parallel data warehouse, all those things. Custom built applications. This is where things like Storm, Spark, Hadoop, things like that come into play. Hadoop actually goes somewhere in between, because Hadoop, as a MapReduce, if you think about the Hive and everything, is going to take longer, but then it has things like Twitter Storm that enable me to have the real-time component also. So it's a different world that we're seeing, and things are going to be made. So there's a difference between doing a database application or a request response application to an event-driven. So in event-driven, we're going to measure is the time that we need to take any given operation. Latency is key. I say this decision needs to be made in less than 30 seconds. Okay, so my full process needs to take maximum 30 seconds, or else I'm losing money. So basically, I can't do request response because one, I don't know if it's responding at the right time, and two, I can't lose anything. Also, I need audit. So this is basically what happens when we go for declarative and temporal systems. This is scenarios where event-driven is more used today. Operational analytics, so systems like the cloud systems, the way they are monitoring is highly event-driven. So everything is sending events. In Windows Azure, you probably already, as anybody saw the Mark Rusinovich presentation about Windows Azure internals. You should see, it's amazing. It goes into a level of detail which is really cool. For this, we only need to know that there is a fabric controller. Fabric controller is what controls everything in the data center. Basically receives information, checks information from everybody, and makes decisions saying, you are not behaving well, so I'm going to shut you down and move the application there. Sometimes I call it the little Skynet, because it's self-aware, it's self-healing, everything, so it's Skynet. Yeah, I'm a Terminator. Other things, web analytics. It's cool to have analytics. It's cool. What about if I could have them now? What about if I could have a portal that would tell me what people are doing, which area of the page is being seen? So for example, if you move your cursor, I want to understand how to have a heat map in real time of where things are happening. I want to understand what's your follow-up in terms of the usage. And sometimes we have browsers that request us to log in with our account. Why would that be? Other than tracking me? So either I choose to yes or I choose no. But that's what's happening. Trying to profile me, trying to understand what I'm doing in order to be smarter. Manufacturing, financial trading. Is this related to big data? What do you think? Is it? It's a good answer. Because now it's, what is big data? Come on, one. At a time, please. Okay, so I searched, Wikipedia knows everything, right? So big data is a term for collecting data sets so large and complex that it becomes difficult to process using on-hand database management tools or traditional data processing applications. What? Excuse me? What does that mean? Big data is about three things. It's the three V's of big data. It's about volume, large chunks of memory. So I have 10 petabytes of data. Amazing, I have big data. Yeah, it's big. That's pretty sure. Velocity. It's small, but it's coming at around 10,000 requests per second. 10,000 events per second. That's big. I need to manage that some way. That's big. Third one, variety. It's coming from all multiple data sources. I'm used to use my relational database and suddenly they start sending me sensor information, Twitter information, Facebook information, all of that crap, and suddenly, what do I do with this? It's about this three V's. That's what big data is. It can go from big data. Sometimes the ingestion of data is also called fast data. How fast do I need to put my data there? So big data can be talking about things like MongoDB, CouchDB, Riot, things like that. That's big data because I need to change the way my data is. So that's the data management piece. But then I can go to the other side and talk about big data as being big data analytics and do things like data warehouse-like approaches with Hive, Hadoop, Hive, MapReduce, and so on. That's also big data, true. But on the other side of the spectrum, which is doing predictive analytics, that's also big data. Machine learning algorithms, all doing real-time decisions, that's also big data. So if we go through, big data is all those elements. That's why big data when we start talking and someone, but that's just me, I'm weird. When someone comes to me and say, I know a lot about big data. About what? Big data. It's a big word for nothing, unless you actually define which part are you talking about. Big data analytics. Oh, I know where to. Is it big data analytics or real-time big data analytics? And suddenly it's like, excuse me? Because there are two things. Big data analytics I can use with Hive, for example. Real-time big data analytics, I cannot use Hive. I probably need something like Spark. So the concepts are different. So, big data technologies goes from relational database, MapReduce, HDFS, NoSQL, real-time indexing, Splunk. Anybody uses Splunk? I love the name. Yeah, I love the name, I love the tool. I actually know one of the guys working there. It's pretty amazing, this system. And the way they receive our logs and do something with them. And I can actually see, almost in real time, what's happening and indexing what's happening in my system. It's pretty amazing. So, this is from Splunk also. I stole it from Glenblock. Basically, we have data coming in from multiple sessions. We basically need to create reporting and visualization. That's being powered by Hadoop. Hadoop has a brilliant ecosystem, and I love even more the names like Hive, Peak, Zookeeper, all those things. It's amazing. Whenever I start looking at the ecosystem, I start laughing because of the name. But it's pretty amazing. So, but one of the things, when someone asks me, what is big data? I always try to understand what they're talking about. It's just that I'm slow, so I need to have a referential map in order for me to get there. Big data. What type of analysis are you doing? Real time? Or is it batch? Okay, batch. Right. Which type of method are you trying to do? Is it something that I want to predict? Is it analyzing something? Because this will decide which tool I should use and where. If you use this matrix, at the end, you know exactly which tool to use. And there are millions of tools in this ecosystem. So it's important for you to understand. Most importantly, what type of analysis are you going to need? Methodology that you're using, the format, the data sources. Those are the most important. Don't forget about the frequency. For example, I have I'm building a system that is not, we were talking and someone said, that's not big data. And I said, yeah, agreed. It's just massive amount of it. It's like, has something like 50 million messages per second being processed. And suddenly, someone decided that, hey, why not do event sourcing with it? So I want to store all the events in the right order because I want to replay them. And suddenly I was like, oh, what have I done? Because storing that thing, yeah, there are real-time databases, but they are expensive. So, but this is the type of systems you can get. So there is a difference between streaming and batch. In batch, I'm always talking about the size of the things. It's not about the time. The time is basically dependent on how many clusters I'm going to put in work. That's what the time is going to take. So it takes 10 minutes. If I throw more clusters, it takes less time. Why? Because the MapReduce is going to, how do you eat an elephant? No harm to the elephant. How do we eat an elephant? Take it in chunks. So basically we chunk the elephant, and in this case, we put several different pieces in everything, and then we process them, and then we join them together. So we map them, reduce them. When you're thinking about streaming, the data is always about hours, minutes. So I'm going to calculate my decision now in real time, but it's basically on information that's happening on a window, something like 5 minutes, 10 minutes, 1 hour, normally an hour. Then analytics happens in minutes, sometimes seconds, and I'm going to show you that. And integration happens in milliseconds. I want to integrate this with my System Center Operations Management. Now, I need to see that in real time. So, is this a silver bullet? It solves everything in the world, right? Big data is going to solve every single thing there is in the world. Is it true or not? When was the last talk that you went that talked about big data and said it's not meant for anything and everything? I normally, when I go to a talk, I tend to leave saying, oh, this is going to be amazing. This is going to solve me everything. And suddenly, didn't solve this one. So it's another tool in our tool belt. Just because I have a hammer, not everything is a nail, right? It might look like, might have a head and everything, but it's not a nail. I need to choose the right tool. So sometimes I need to mix and match, even within big data. And this is important because right now, so suddenly we started talking about big data and everybody's going wild, ballistic. And yeah, big data is going to enable me to basically through monitoring all everybody's calls and how they work internally and how they operate in the web, all their social feeds. I'm going to follow him, I'm going to provide all the profile, and I'm going to be able to enhance my sales in 3,000%. Yeah, that might not go there. Or, oh, I'm going to do this and it's going to be cheap to do it. Because we're going to use the cloud, and the cloud is all about cost, right? It's always cheaper when we go into the cloud, right? So if I today don't do any kind of analytics, and suddenly I put the big data analytics, something like Hadoop or Strata and everything, or Spark, it's going to be cheaper, right? Of course not. I didn't have it in the first place. What's going to allow me is to increase my revenue, because I have two ways to get profit, right? Either I decrease my cost or I increase my revenue. So you need to manage those expectations, because right now the expectations are here. That's pretty much the silver bullet. And you start to build something and suddenly, I don't know if you have this already, but sometimes we go and say, this is amazing, this is really cool, and then we do a brilliant work in doing a POC and suddenly the person on the other side goes, is that it? It's done? Come on. I was expecting this to fly and everything. No, that's it. We need to manage those expectations. So, critical things in order to survive. How large is my data? How fast is my data? Where is it coming from? What type of analytics should I do with it? This is the questions I need to know before I commit to anything. This is some of the questions I do. Because there are several options. Analytical, pretty simple right now because we can leverage all our experience in big data, in BI. Machine learning. Who already went and started to learn or done anything in machine learning? It's pretty amazing. I've been trying to build a robot. Anyone knows the Rumba robots that go and vacuum cleaners? It's amazing. They go through the house. You know they are hackable, right? So I went and I convinced my wife that she needed a Rumba because I was a good husband. And suddenly the Rumba started to go, and I started looking at the Rumba and saying, hey, you're getting hacked. So suddenly, hey, this is where your waste goes. Gone. Hey, here's a Raspberry Pi. put it in, and your brain is crap. I don't like your brain. So I'm going to put your brain with Raspberry Pi. Basically, I have too many free time on my hands. And then starting to send information to the cloud, and basically create a map of my house. So now Rumba knows exactly where he needs to go. And if you put in front of him, hopefully, he will have the perception that that thing wasn't there. So I'm using both historical information and real-time information to understand, okay, this thing wasn't here, so probably is a movable object. So the next thing I'm going to do is put something in order for him to speak to me. So kind of Cortana kind of thing in order to say, move out of the way. And that's pretty cool. The only thing is now the damn thing doesn't work too well. And my wife hates it. Because it doesn't have the purpose why it was bought. But it's fine. It's cool. It's really nice. When we develop machine learning, it's pretty cool. It changes every concept that we have, but it's pretty cool. You suddenly, have you got that feeling sometimes that you see something, and after you understand and you experiment it, you start seeing that pattern being used everywhere? Have you had that experience? Like, for example, we go and we talk about the design pattern, like repository pattern. And suddenly we explain, and we look, and suddenly it's like, yeah, I can use this here, there, there, there. Suddenly everything lights up. When you learn something like this, you start to look at your business, and suddenly it's like, yeah, I could use machine learning. An example is an airline, which is running, I'm not going to tell the name, that had artificial intelligence for 2 years, running, understanding, receiving all the information from what people were doing, their salespeople, doing in terms of changing the pricings. And he was learning. So today is very good, and then they changed the price up. Okay. So there is going to be an event on this day, and the price went up. And he started to learn for 2 years. And now, it's connecting with something like weather systems, news systems, with event calendars, everything. It's the one that does the decisions in terms of how much the price is for that specific flight. And while a little while ago we had tricks, how many of you knew the tricks when not to buy tickets? Anyone? There were tricks like Monday, it's a bad time to buy a ticket because we all know it's starting of the week. As soon as we go, we sit down and we say, I need the holidays. And so if you go online, it's actually more expensive. Then, at the end, at the middle of the week, around Wednesday, around noon, we're in the middle, and we're like, so many meetings, so many things, I really need the rest. And you go again and try to search. So, bad timing again. And then, it's somewhere on Friday, because, oh, it's the end of the weekend, it's the weekend, I really need to go somewhere. Bad. So try to avoid those, and you'll be safe. Most of them still don't have those Skynet systems trying to learn from you what's happening and changing. So you're still safe for now, until we sell more of those. So this is important. An example, nerd sensor data. So would it be cool? So we have something like 120 sensors, this nerd sensor data, 120 sensors, 30 samples per second per sensor. Basically every sensor tells you what's the temperature, the moist, all of those elements. Would it be cool? We have something like 4.3 billion samples a day that we need to process. This is housed in Hadoop. And I have here example. done by Microsoft. Wayne Yee from Microsoft, he's now in research. What if I could connect to sensors all over the world and receive information, and from that bulk of information, which is basically a text file saying sensor A, this is the temperature, this is the wind speed, this is everything. Would it be cool for me to create this? So basically what's happening here is I can go and map somewhere. So it's basically places that are already mapped. Hey, please. Come on. Doesn't hurt. So let me go again. Just use this one. A. So how is this getting generated? What happens in TV when we're seeing the weather channel for some reason? What happens? How do they generate that? How can I predict how the weather is going to be like? I need to have historical information, and I need to have now, and basically with the now, with the history, I can predict what's going to happen. So basically what's happening here is, based on that historic information and the now, they're able to feed that data into a Hadoop cluster that creates the historical information. Then they have the now information, and leveraging, in this case, I think it's Swedish storm. And then they have HPC generating, this is an animated GIF that is being generated. So based on their predictions, they have predictive analytics. They say in 1 hour it's going to be like this. They basically create an image. Then HPC comes, grabs all the images, and puts an animated GIF. And you start to get this. And from those 4.3 billion information a day, you start to get this, which is something now you can do something. Because if you go through, let me grab something from the processing queue. If you go through, so those are the thumbnails, several thumbnails that I have just before they are processed. This is the full-time animation. So apparently there's going to rain. And this is the information about what we're doing, and there's all the logs of what's happening, what's being processed, and this is HPC here doing a lot of work. But this is basically big data and real-time analytics are only interesting if at the end of the day I have something where I can look and make decisions. Either I do the decisions or a machine is doing them for me, but that needs to take all that data, crunch it together, and release that data afterwards. Because if you just throw me your Facebook data, it's like, yeah, I don't know what I need to do with it. Right? It's just huge amounts of data. So, what's the approach? Architecture patterns. Anyone knows event-driven architectures? One at a time. What's event-driven? An example. Tell me a system which is event-driven. Windows? Yeah. In some cases. So, we're going there, and event-driven architecture is basically a different paradigm. So we have SOA 1, then we got SOA 2, Service-Oriented Architecture 2, also known as Event-Driven Architecture, EDA. What is this? It's basically, with SOA, what we do is, how many of you have ESBs? enterprise service bus in your company. Or something like BizTalk, TIBCO, WSO2, things like that. The concept was everything is a service. Everything needs to go and connect through those elements. And I will have BizTalk or TIBCO doing orchestrations in the middle. What have I done into my architecture? What happens if I have everybody connecting to this service? What happens if I pull the plug on that service? Everything stops. I was with a customer and they were saying, this is very robust. And I said, I bet with you that in 1 second, I'll drop everything. And he said, that's a bet. I went, took the cable off. And he's like, that's not fair. You didn't place the ground rules. Basically, I said I could do it. Basically, in SO 1, I'm putting one element in the middle, which is, yes, it's helping me connect, but it's also, at the same time, a single point of failure. I need to have HA, I can't have HA and everything. But it's still intrusive. It's in the middle of the process. So, what's the solution? Event-driven. Basically, the concept is, imagine that I have, and I like to give this, this example, 2 integration methodologies. I have basically a village that in the middle, what there is, it's actually a river separating 2 margins. SOA 1, what tells me is that the way I'm going to integrate is actually to put the line from one to the other, and basically one sends the information, sends, for example, a message on a bucket, the other guy on the other side receives the message. If I cut it, it's gone. If I need to translate, because imagine for some reason in each margin they don't speak the same language, it's just like Portugal and Spain. You cross a river and suddenly, oh, why are they speaking funny? Oh no, it's fine. So I need to do translation. That's your orchestration taking place. But again, I'm only giving, and what happens in it, I'm saying that normally in applications I say this application connects with that application, this is the orchestration. So it's like putting, for every person on the one side and the other, I need to put lines between them. Is that the best way? What would solve the damn problem once and for all? Bridge, right? You build a bridge, and then they take their legs, go to the other side. So, event-driven, the concept is creating that bridge. He's saying, okay, the application is going to throw into like a river of information where messages are passing through. I'm going to put here an event saying, I'm buying something, some pair of shoes. So, and it's not only about the execution. There are 4 types of events. There is business event, so I'm interested in, I'm buying, this is how much. The execution, there was actually the sale was done, but there is also operational. In order for me to do the sale, I first had to go get into my back of my store, grab that, give it to him. All of that is part, and also the life cycle. I started fulfilling the order. I started connecting with this and that. And this is what's going to give me all the information. And now, it's when I start to get all events, millions and millions of events. But then I can do some things, which is cool. I can either use simple event processing, which is something that I'm only looking at in that stream, in that river, there's only one type of event going. So it's simple. Or stream. There are multiple, but I'm only interested in one. For me, those are the notable ones. So the rest is crap, I couldn't even care less. And then there is complex. What's complex? It's when I start to say, I want to find this pattern. If this event happens followed by this other event and this other event in this order over a period of time of this, with the average price of this, I want to act. Right? The no-brainers. How do you do this with the current SOA 1, mostly SOA 1 implementations we have? We don't. We don't. Is BizTalk and TIBCO going away? No. The only way it differs is that now, instead of them being in the middle, they can connect with the same pipe I'm connecting to. And they cannot be in the middle and still do their processes. Because there are still things that I need to go through workflows and everything. I just don't need to meet in the middle. Okay? Makes sense? Going crazy? No? A little bit of both? Questions? So far? Comments? Personal attacks or other? Okay,
Is
nice.
there software out there that does this? Is this like...
Yeah. There's a lot of software, and Service Bus is one. WSO2 has the capability to do that. But one of the interesting things in event-driven is that you can actually pull off a complete system very quickly. Very quickly. I'm going to show you something that I built just to explain you what the concept is. And it took me around 30 minutes in order to do. And basically I said, this is the generates events. This is the patterns I want to chase and I want to target. And this is the actions I want to get. So when I integrate now applications in this paradigm, I can even either use TIBCO, BizTalk, or any other thing if they are very complex, or I can do a very small adapter that the only thing that needs to know is its application and the channel, nothing else. If the other applications change, if I need to plug in some new security system, audit system, whatever, I can. It doesn't need to be in between. It's just a river. I just look and I see things passing and I grab whatever I need. So, scenarios. This is a scenario in manufacturing. So basically, all the information sensors in the plant are sending information. What are we doing? What's the level? What's the quality bars? Everything is sending information. Basically, we send it to that stream data source, and then with the event processing. And this is for historical information. I normally try, it doesn't require you to store all the events, but I would recommend that at least the events you act upon, you should store them. Because there is one thing called audit that people tend to like to do. Say, why was this decision made? And you will have that proof of why you made that decision. So, you have historical data, but also you have event processing saying there's thresholds. If the production is going below this number, I need to immediately, if I'm a car manufacturer, I need to immediately send to sales the information that the car is going to be available a month later. I don't need anyone to tell me that if I have sensors. So that's why I call it Skynet. And this is, as anything, design patterns, any pattern, can be a pattern and an anti-pattern. Depends if you use it correctly in the right problem statement or not. And so you need to always understand, okay, what is my time to market? What is my reusability, simplicity, performance? What do I need? Based on that, I'm going to try to choose which architecture pattern I'm going to use. Just because I have a hammer, not everything is a nail. So using always the same pattern is the same thing as saying, Who does Windows Phone applications or Windows applications? And then does iOS application and things like that. MVVM, you know MVVM, model view model. So you do, and you use it in Windows development, in Windows Phone development. It's amazing. Go talk with someone from the iOS world or the Android world and say, I'm going to use MVVM. You're going to get slapped. It's not the right pattern for those developments. So you need to adjust the patterns with what you're doing, what problem are you trying to solve. The MVVM one not being the right for them, that's a different conversation. It will take a long time. Okay, so how do we get business value? We basically get, the end goal is to increase profit. We either increase the revenue or decrease cost. So you're probably like this a little bit. Who's this crazy guy talking about? You want to see some examples of this that help. Okay. Case studies. Fraud detection. Fraud detection is a very cool one because I've already built some. Data sources. I have anti-money laundering database because we already have a couple of information that we can use in order to detect if it's a fraud or not. And then we have the customer transaction. We use normally there statistical information and artificial intelligence. Why? Statistical information is going to tell me like the probability of this being a fraud is 75%, 25%, 10%. Similar to spam, right? Artificial intelligence is basically understanding from those elements that I normally have from history, learning from them in order to get in real time to be able to get that quote. So an example of implementation we built was with the customer transactions and the money laundering, we basically send this to an event channel. This event channel had everything. So all the customer information, everything in there. And all those things were being sent to a data lake, which is in Hadoop, so basically where we place all our data. It's a big data, so it has to be in a big place. So it's a data lake. If it's even bigger, it can be a data ocean, something like that. Then we process it with Hadoop or with HPC, some kind of those things. And suspicious. In this case, we use Hadoop here. We use the processing. We use machine learning algorithms. And then we identified as being suspicious. And then there was someone actually validating those elements and seeing, is this suspicious? And that's where the artificial intelligence started to kick in. Okay, I have the decision. This is what the decision of the person. Did I get it right? Did not get it right? Then the other stream, which is now in real time, I'm doing and checking already based on every customer transaction. Immediately I ask the artificial intelligence, what's the score for this? And it tells me 25% and say, I'm okay. 75%, oi, hold on, sorry, you're not going to do this. Might be wrong. It's better to be safe than sorry. So you basically go and say, hey, of course, Windows Phone. Hey, here's the police. There's someone that is actually using this card somewhere else. And you suddenly go there, hopefully, and they'll catch it. Hopefully. In the cloud, what did this do? How did the cloud help here? If I deploy this on the cloud. So this was an Hadoop cluster. This had about 250 instances running. This one. In here, this event stream processing is actually small, only had 10 instances. The event channel was an in-memory event channel because of the number of systems. There are other stuff. If you want to take it to the next level, you go UDP level, socket level. It's not that cool, but it's where you get the best performance. So how do you think the cloud would help me here? Managing this problem, managing all this data and all those decisions. Would it cut costs or increase revenue? Come on. Who votes on increased costs? Decrease costs?
If you can scale down at night or something maybe.
Who votes on increased revenue? It doesn't increase revenue. It actually enables you not to lose it, that's right. But it doesn't increase. And in the cost, yes, it's more cost, but actually the cloud will make it less costly than if I go to on-prem. Because the same cluster on-prem, it's very expensive. Very, very expensive. So in here it's the cost. But it's true. If I didn't have this before, I wouldn't see the cost being cut. But comparing apples with apples, same thing in the cloud, same thing on-premise, the cost is going to go down. And yes, in this case, those were 250. And the scaling of those things had to do with the number of events that were being sent. So if there was a lower in terms of operations, the number of instances would go down exactly at the same time. Another thing, fleet management. Who already done anything related to fleet management? Anyone? It's pretty cool. You basically have geolocation data from all the trucks. There were, in this case, there were a company that had something like 20,000 trucks sending geo information every single second. We then went and said, yeah, every second might not be a very good thing. 5 seconds intervals is good enough. Because the goal was to provide several things. And through artificial intelligence and statistics, what we did was we wanted to first have information about, is this driver being cautious and going through the right routes that we define? So if I have a route that he needs to follow, and he suddenly is not en route, I need to do something. I need to, it's like, have you gone after a car like, hey, if I'm a reckless driver, call this number, or something like that. And you suddenly think, I should do it, actually. So it's in order to prevent that. And so you know exactly where the truck is, why it's going, and then you can start doing interesting things like, imagine this would be released on an application, and this would be included on school buses. In the US, this is massive because almost every kid goes to school in a school bus. And I am a father, and I want to go and pick up my daughter from the bus stop. And so I could have in real-time tracking where the bus is, and know exactly where the bus for my daughter is. So immediate alerts. This is using Twitter Storm. So everything is going to Hadoop storage. Everything is, in this case, HDFS. Real-time Twitter Storm is looking at HDFS. Then batch computing. Batch computing, MapReduce. So basically what we're doing here is we're basically here going through all the information, crunching the information, and trying to find what is the patterns that you normally use, how much do you spend, and how can I cut in tax, or how can I cut the cost. For example, you keep going through this route, but this is not the best one because you need to pay something in the middle. So you need to adjust. And then shortest path algorithm. So some artificial intelligence to understand what's the best route for me to take. If you go this in the cloud, this is the way this geolocation will be done is actually sending this information to the HDFS. The problem is, what about this HDFS is not there? For some reason there was a brownout. I need to throw this into some kind of queue which supports this. Perfect queue would be Service Bus, Windows Azure Service Bus, for example. Or I could use others, RabbitMQ, things like that. In here, cost, again. Last one is customer engagement. I want to understand and profile my customer. So, I'm Xbox One. How many of you have Xbox Ones? So you should have been in build because apparently they won one. So customer engagement on Xbox One, I'm trying to create a hype around my Xbox, and I'm trying to understand how many should I produce. So I started talking about Xbox One, I started sending, and then I started monitoring Twitter, Facebook, I started talking about Xbox.com, but then I started also understanding several different stores. How's the pre-orders going? Because based on that, I understand how's the engagement, and I can actually target my manufacturing to have those numbers. And of course, the goal is that there is always someone on the first day that doesn't receive it. It's just the way things work. If it's basically sold out, it should be really, really good. It doesn't matter if there was only one unit to sell. It's sold out. So next day, everybody comes in and tries to buy it because it was sold out on the first day. Marketing strategy, I'm learning stuff. So for this, data source is basically several. Twitter, it's Facebook, crunching everything. In Hadoop storage, crunching this, and understanding customer sentiment. So this is data source, this is going through here, Service Bus, and then Hadoop storage, processing customer sentiment. In real time, things like I want to understand exactly on this precise moment the sentiment in order to someone in Microsoft, as soon as someone gives a bad review, oh, this doesn't work because it doesn't have this capability versus PS4, suddenly in the next 5 minutes, there's someone replying and saying, no, it actually does this and that. And suddenly you won a little bit. So it's basically Big Brother is among us. And real-time pattern matching. For example, if I see that, for that I need to have very well the profile of the person already. But if I see that the person is going from different websites, the same person, same IP address, is going game.com, oh, it's not available. Amazon.com, no, it's not available. Oh, Tesco, it's not available, and so on. I know that person is looking for. So I know how to measure how many people are looking for that thing. And so I can engage with them. I can, for example, say, okay, if you go here, you might get a chance to win an Xbox. And suddenly everybody goes there. And you suddenly increase the engagement. If you download this app, you're going to participate in a giveaway of an Xbox. We'll basically choose one randomly. And suddenly, as soon as they have the application in their phone, what better way to engage with them? You're basically hooked, apart from that. So again, a lot of interesting things. What happens here? What does the cloud do? It enhances the customer engagement. It enables me to have more revenue because I now know my customer better. Imagine that I'm going to a store and the store tracks everything that I used to normally spend there, and then send me information, detailed information at the end of the year saying you spent this much on this, And for your health, we would recommend you to cut a little bit on this and on that. Would that be cool? What would be your experience as a customer at that store? It's like, oh, they really are interested in my well-being. Yes, they are.
My loyalty color.
Exactly. Yes, they are. Very interested in increasing, but that is creating trust. Because I trust them, because I'm buying from them, and they are giving me something back. My data, not pushing me a sale, but suddenly I increase my trust with them. So if I have to choose between two, I will buy from them. This is what real-time information, when managed with batch processing, can give you. Is this interesting? Have you thought about this before? No? When people go and say, oh no, those things, people tracking us online, and it's in a couple of years from now. No, it's not. It's already here. I don't know a couple of guys that did. I'm one of them. So I'm part of the guys that are building.
What am I having for dinner?
I don't know. Let me ask. I don't have my Cortana, because Cortana will know. So, what I thought it would be interesting is for you to understand, when we talk about complex event processing and doing all these things, what's the complexity? So imagine this scenario. I have a very small class, which is my tick class. Tick is basically my index. And this was done because at the time someone was talking about stocks and everything, and I just tweaked it. So imagine I have stock information, which has the symbol, the price, and the time that it happened. Just simple. I have a generator that basically goes and randomly generates between these accepted symbols. So Microsoft, AWS, Google, Apple, all those things. And basically generates a tick. Start generating ticks randomly. And I have the same thing for another type, which is sentiment. So I'm basically, imagine that I'm receiving this in raw format. I'm translating this into a sentiment. So I basically receive everything from Facebook, Twitter. I calculate the sentiment and basically put the message saying, this is the sentiment on this precise index right now. And so I then can correlate. Because sometimes I want to have, so if this index is this much followed by that one, but if the sentiment is low, I don't want it. So creating this generator, I'm using here one thing, which is Nesper. Anyone knows Nesper or Esper? It's basically, Esper is a complex event processing engine framework, open source, and Nesper is the .NET port of that Java framework. You would immediately know that was a Java port done by Java people. I would even start by names, like, yeah, this is Java, pretty sure. And was done by a code generator, pretty sure also. But it's pretty good. So I basically have my configuration and say, hey, complex event processing engine. I'm going to have in this stream, I'm going to have two types of events. One is tick event, which I'm going to say stock tick, and the other one is the sentiment kind of event. I'm going to start sending information. So I have here the generator. So in the generator, what I want to do then is, wouldn't it be cool if I was able to just think about my capabilities in SQL and use a SQL-like kind of query language for real time? And say, please give me all the stock ticks that go in this event stream. What does this do? As soon as we start, a lot of events generated. What's this generating? Basically randomly creating events. This is probably on this machine, this is a small machine, we're probably around 100,000 events being generated per second. So it's a small machine, but still generates a lot of crap. So does this help you in any way? Not precisely, but at least I can see that I can do queries even in a stream of stuff. I can actually query them. Now, what it would be interesting is, can I have a different kind of event? So I have the two events being generated, but I was only looking for one. I was doing stream event processing, specific one. Now, what I'm going to do is, I actually want, and I have different views for both. So I have a sentiment here. This sentiment here, and I have a stock tick being generated. Okay, so in the middle of the stream, I'm now able to query both independently and do things differently with both. What happens, wouldn't it be cool for me if I could, instead of this, because this is very simple, if I could do something else, like a more complex, like, okay, I'm not interested in everything. What I'm interested in is, please give me all the stock ticks which have Microsoft MSFT has the symbol going through that pipe in a window of 2 seconds. So give me all the events with symbol being Microsoft in a 2-second window where the average price over that 2-second window is 1.7, more than 1.7. Now we're getting some pattern matching. And suddenly, it should start to go slightly slower, still quick, but slightly slower. Why? Because I now, if I check, I only have where the prices are higher, the average is higher than 1.7. So I'm not targeting everything, I'm only targeting that specific element. Why not going further? Why not going, and again, in here, we're using some kind of mix of almost SQL with some more things. This is called EPL, Event Processing Language. So basically what I'm here saying is, please select everything that meets this specific pattern over a window of 2 seconds that meets that pattern. What is the pattern? Is I want that to every single Microsoft tick. This one says followed, so I have a sequence that I'm looking for. Followed by an AWS tick with a price lower than 1. Followed by a Google tick with a price lower than 1. I only want those, nothing else. So suddenly, oh crap, I think pretty much. So if I go now, I see that Now it's a lot slower, what I can see. And if I stop it and I look at what's coming in, I'm seeing that, okay, this pattern was found. What was the value of the Microsoft symbol when? What was the value of the AWS symbol and Google, in order to make sure that it was actually according to that pattern. But this is still only thinking of a single type of event. What about if I mix the two together? Can I find only patterns in specific types of event, only one? Or can I mix them? I can mix them. So if I go and say, comment this one. And now, what I'm going to say is, okay, the pattern that I'm going to look after is actually the same thing as before, so all the sequence in terms of ticks. But if this happened, but the sentiment over Microsoft is good, then only then I'm interested. So I'm now mixing them together. I'm looking at basically each of the generators is generating 100,000 events. So I'm basically working with 200,000 events per second. I'm trying to find a pattern within those numbers, which actually is a sequence of events with a specific value over a 2-second period, and I'm mixing the two together. And basically, I start seeing a lot less coming in, because now I have a lot more in order to search to. And it's not rocket science. At the end of the day, this is just like we learned SQL. We just have something. It's like every means that I'm not going to evaluate just the first. Is every single event that actually matches this specific pattern followed. This is followed by any other event with AWS with this value, followed by any other event with this value, followed by this type of event. So it's, what do I need to do in terms of pipeline? The only thing I would need to do in order to put this in a production system, in order to support more, is changing the event channel from my in-memory machine to service bus to any other thing. That's where any service bus comes into play, message handler.net comes into play. All those big boys come into play. If you want the best capability you can have in terms of more events per second, there's nothing better than you controlling sockets. But that's extremely, extremely costly from a sanity perspective and also from a money perspective. So normally what you do is the same thing as you do anywhere. You shard these things. Twitter Storm, for example, also does this as an expert. Stream event processing, complex event processing. I can make patterns. I can look at the Hadoop HDFS. I can actually look, if you go online, there's actually a project from a friend of mine from London, Richard Conway, which is the connection for Storm into Service Bus. Because at the end of the day, it's a message that needs to go through somewhere. If I have it in Service Bus, it's in Service Bus. I still need to understand the patterns. And for example, I can have my workers receiving the information, grabbing the message. But while the message is in there, I want to do decisions based on that. I want to feed monitoring information. So this is the power of real-time data management. So the goal of this session was to allow you to think differently from a data management perspective. Think that it's not about only the size of the data, where the data comes from, is much more. You can do a lot more with your data today. If you, instead of just throwing it away, try to understand it and try to do something with it. Because it only makes sense if we have the right data available at the right time for the right person. That's the secret in order for having the real value. Is when you put the right data in front of the right person at the exact time. So if I'm operating Windows Azure, I want to receive in my screen popping, jumping, red, pinching me, saying there is something happening in there. You need to act. And I don't want to have those alerts saying the machine is down. Why do I care? Those kinds of things needs to be automated. Who uses runbooks or playbooks in the company? So some way of automating the processes of backup, restore, or DR, or something like that. If you have a PowerShell script, for example, I want that when this happens, when I have a brownout, when in my monitoring I'm seeing a brownout, I want to immediately go to DR. I can actually put some system like this looking for that pattern, because I'm basically thinking, what do I do normally? I look for this, then look at this, then look at that. Okay, I created a pattern, now I look for it, and as soon as it comes up, I immediately say, now execute this. And the brainless decisions are automated. Now, please only call me when there's something really serious. And the result, the end result, and my goal with this is for me to create an application where I can control my business and I can be somewhere in the Caribbean with my foot on the water and say, yeah, and not be bothered by anything that is not business critical. So this is the goal, is getting right data, right time to the right person. The strategy, there's no single strategy. If someone goes and tells, in order to do that, in order to sentiment analysis, it's only Hadoop. No, it's not. You're losing a huge amount of information that is happening now. If you only know that in 10 minutes from now, it might be late. For example, what happened to the movie John, what was that thing? It was a movie from Disney that cost a lot of John Carter. What if they have actually been monitoring on the first day, on the first hours of the release? They could have saved a lot of money to a lot of people. Because first day was like everybody to the cinema. Second day was nobody. So they need to have real time. It's not only about historical data, it's now. Matching both is where you get the benefits. Thank you. Questions? Comments? Personal attack or others?
Is there anything nice for writing EPL so that someone in marketing could put together bits?
Unfortunately not.
No?
Unfortunately not. There's starting to appear a couple of tools that we're trying to translate, but right now, no. Right now, it's very much what I normally do. I have a tool that I already built, where basically I know their KPIs, and they say this is how, and I generate on the back. Basically, like Link does. I'm expecting someone to do a Link to EPL. Hopefully, please. I don't want it. More questions? Was the session helpful? Was what we were expecting, more or less? More or less. Is that a good thing or a bad thing? Okay, thank you very much. Hope you get a great rest of the event. And if you need more information, just I'll be online at any time. Just tweet, just drop me an email. I'll try to help. Okay? Thank you.